has been my great pleasure and honor to share with you my idea of how ICT can help achieve the SDGs this morning. As has been introduced by Mr. Ishibashi, I'm currently Emeritus Professor of Waseda University, but also I am a part-time lecturer at the UEC. My short biography is I have received in 1958, when I was 18 years old, a diploma. That is to say, I have graduated from Bountiful High School, Utah, USA, as an AFS American Field Service exchange student. And I have graduated from the University of Tokyo, after obtaining Bachelor of Electrical Engineering, joined NTT's laboratories, and from 1967 to 1999, for 32 years, I worked at NTT, mostly laboratories, but sometimes at headquarters, etc. In 1974, NTT has sent me to University of Essex in United Kingdom, and I have received there Master of Electrical Engineering Science. In 1979, I have received Doctor of Engineering from the University of Tokyo, Japan. Besides my research activities, I was active at the international standardization activities at ITU, International Telecommunication Union, headquartered in Geneva, Switzerland. I was chair of a working party, and then for 8 years I have been chair of ITUT Study Group 11. Then I was a visiting professor of the University of Edinburgh, UK. Then I have graduated, so to speak, from NTT and became professor of Waseda University, Graduate School of Global Information Telecommunication Studies and of Asia Pacific Studies. Okay, and now let's go into the technical aspects. The ongoing fourth industrial revolution. First industrial revolution was using water power and steam power, and as a result, weaving machines and locomotives powered by water or by steam engine was the driver. Second revolution was mass production of cars, telegraphs and telephones, and electric power generators. So this time, driving power was not any longer water or steam engine, but by electricity. Third industrial revolution was in late 20th centuries. Computer and automation was brought in the industry. Computer-controlled machines, assembly lines, and this was called digital revolution. Fourth, early 21st century, now ongoing, internetworking of computer-controlled machines and various sensors. This is called digital transformation, often abbreviated as DX. Smart factory, smart city, smart agriculture are some of the examples. This shows that there was a paradigm shift in technology development. Ongoing fourth industrial revolution is ushering in a paradigm shift in technology development as follows. from up to 1970s sees technology-oriented development, then up to 2000 market needs-oriented development, then currently social problem solution-oriented development, for example aligned with United Nations Sustainable Development Goals or SDGs. As you have already seen this view graph, these 17 SDGs were agreed in 2015 by United Nations General Assembly unanimously. Just to look at first three, for example, SDG 1 is no poverty, SDG 2 is zero hunger, SDG 3 is good health and well-being, and so on. Current social problems around the world and their relevant SDGs. Due to the lack of time, this lecture focuses on the following problems. Food and agriculture, SDG 1, no poverty, SDG 2, zero hunger, SDG 12, responsible consumption and production. Urban problems, SDG 11, sustainable cities and communities. Gender equality and reduced inequalities. SDG 4, gender equality, and SDG 10, reduced inequalities. However, I have found that given only 20 minutes, I could concentrate only on food and agriculture aspect in this lecture. Current social problems around the world and their relevant SDGs. Other social problems to which this lecture will not refer and their relevant SDGs are health and well-being, SDG 3, good health and well-being, SDG 6, clean water and sanitation, climate change and environment, SDG 12, responsible consumption and production, SDG 13, climate action, SDG 14, life below water, SDG 15, life on land, energy, SDG 7, affordable and clean energy, safety and disaster preparedness, SDG 13, climate action, inequalities other than gender inequality, SDG 10, reduced inequalities, such as those based on disability and or race. Now let's focus on food and agriculture problem worldwide. Worldwide grain production and consumption per person. The graph on the left shows that grain production per person 347 kilograms exceeds grain consumption per person 180 kilograms per person. And on the right hand side, this view graph shows that 89% of the people are well fed. This is about 6.4 billion people. However, 11% of the total world population are not well fed. This is about 0.8 billion people. So the problem is, although total grain production exceeds the total need of world population, grains are not distributed evenly among the people. Reason: A, uneven production by region, B, poverty to buy grain, C, war and conflicts, and D, food loss. ICT contribution to solve problems A through C is not much. However, for reason D, that is food loss and waste, ICT can contribute to share information among relevant bodies. I will show you later by a slide. The next view graph shows food and agriculture problem in Japan. First, problem 1, decreasing number of farmers, as this view graph on the left shows. And problem 2, aging farmers. Right now, over 70% of farmers in Japan are over 60 years old. So our farmers are aging. This is a particular problem for Japan, but I understand that some of ASEAN countries suffer the same problem. ICT can contribute by enhancing productivity and profitability of farming and thus attracting more young people to agriculture. Now, I would like to show you some examples of smart agriculture to achieve UN SDGs. Agriculture and food-related businesses would be the next promising industry where lots of innovations are taking place. This smart agriculture relates to SDG 2, Zero Hunger, and SDG 9, Industry Innovation and Infrastructure. I would like to show you a smart agriculture introduction video made by National Agriculture and Food Research Organization, NARO, of Japan. Sorry, this video is only in Japanese with a short English subtitle. So let's just see it. As the next example, I would like to share with you Panasonic's vegetable factory. This video is also in Japanese with a short English subtitle. So let us watch. Now let's turn to food waste problem. Worldwide food waste is a great burden on the environment as well as on cities' budget, cleanup budget, and cleanup people. If food wastage were a country, it would be the third largest greenhouse gas emitter, only after China and United States of America. So, a reduction of food waste worldwide will help achieve SDG 12, responsible consumption and production, and SDG 13, climate action. Measures against food waste, for example, we can say that food bank is such a measure. From on the left side, farmers and food production industries, food bank gets food and food materials and distributes them to welfare facilities, single mother families, poor families, and local food deliveries. There are some 80 food banks across Japan. ICT is used for information exchange and storage among participating. Another example of food waste is USA's Spoiler Alert. This is a new venture business started by two young graduates of MBA, MIT, Massachusetts Institute of Technology. And this is called Spoiler Alert, using basic ICT technologies. They refer to SDG 2, Zero Hunger, especially to food deliveries to poor people or people living on the street. I'm running out of time. So to conclude, ICT would contribute to achieve SDGs in cooperation with other partners, basically to collect, exchange, and store data among partners. For that purpose, I would like to stress especially the standardization of databases for storing data, the effective use of stored data, AI, artificial intelligence, and also robotics based on artificial intelligence. Thank you very much. Sorry for exceeding time.